Okay, so when we look at the relationship between the magnitude of a natural hazard versus its frequency of occurrence, we see that they are inversely related. This is called the magnitude frequency concept, okay? We see that they're inversely related. So magnitude itself means the amount of energy that is related in a specific event, and by frequency, I mean the interval between occurrences of an event. So their inverse relationship means that usually the greater the magnitude hazard, such as an earthquake of, for example, the one that happened in Idaho in April of 2020, it tends to happen less often, in our case about every 30 to 40 years or so, than a smaller hazard, such as an earthquake of magnitudes 2 or 3, which are very common in Idaho, especially in the east area near Yellowstone, for example. So again, a greater magnitude 1 doesn't happen nearly as often. A lower magnitude 1, as you see, makes the frequency be much greater. There are two main ways in which humans can react to a natural hazard. One is going to be the reactive response, and the second one is going to be the anticipatory response. So the reactive response is going to happen after the natural hazard actually occurs. So responding reactively will involve direct effects such as responding to deaths, responding to injuries, to property damages, and also indirect effects like estimating and gathering the funds for the cost to later on recover, and things like providing enough emotional assistance to those in distress after the effect. So within this reactive response, there will be four main stages. The emergency stage is first, followed by the restoration stage, then the reconstruction 1 stage, and finally followed by the reconstruction 2 stage. We see that in the first three stages, post-hazard or after the hazard occurs, most of the actions are fully reactive, just trying to basically patch the holes and get things back to where they were before. And we see that for the last stage in the reconstruction 2 stage, there is a bit of anticipatory response, meaning there is some developments that are made towards stronger infrastructure, for example, so preventative responses, if you would. But we see that if they get to this stage, to the reconstruction 2 stage, it typically won't happen until about 2 years after the event occurs. So this gives you a number of weeks, and we see that this stage might happen a little less than 100 weeks after the event occurs, which is close to 2 years. But overall, the reactive response simply tries to get things back to how they were before the event occurred. This slide here now shows us what an anticipatory response can look like. So we see that in an anticipatory response happens, or how it happens is that it occurs prior to the natural hazard occurring. So what it tries to do is to avoid hazards, or at least to avoid disasters or catastrophes, by the measures that are taken prior to the event. Or it tries to adjust to hazards and adapt to them from previous experience that they have had with that same natural process occurring. So examples of anticipatory responses would be things like appropriate use of lands and soils, having insurance in case a hazard were to occur, having a plan and execute evacuation if it's required, having a disaster preparedness team and plans in place, and have these actually be communicated to the public, and also anticipatory control of natural processes, like what you're seeing in the two images here on the right. So the top one here shows you a man-made flood barrier that prevents the higher water level from flooding the neighborhoods and the roads. The second one over here is a fireman that is carrying prescription burns that allow us to have control over how much could actually burn in the future. And with these types of vegetation, if we do this, the types of vegetation that we burn will allow for the wildfire that does occur in the future to delay the burn, as we have already burned the vegetation that burns rapidly. So this is a common practice, as we'll see in the chapter, what is that? I think 13, or yeah, chapter 13, I believe. So we'll see one of those anticipatory responses definitely be implemented. And this prescription burns happen here in the northern hemisphere, typically in the later fall or even earlier in the winter, so somewhere in November and December usually. And although you can see them in the spring, they usually happen later in the year. Another example that I can think of for anticipatory responses is the removal of dead fuel for dead wildfires, for example. So dead fuel could be fallen trees or dead leaves. Or, for example, having a location at your home where you know you'll be safe from a tornado, like a tornado room or a basement for the most part. Again, you should take anticipatory responses based on the location where you're at and what kind of hazards you should be expecting. So many a times, just so you're aware, this anticipatory response we name mitigation. So you'll see them kind of interchange every now and then. All right, so thus far we've taken kind of a negative tone towards hazards, meaning we've been talking about their potential for destruction and damage. However, there are many good things that a hazard can, or a natural hazard can bring about with it as well. Sometimes it is in the short term and sometimes in a slightly longer term. As an example, in the images that you see here on the slide, you see rock that has been solidified from lava, right? So here you actually see the lava still solidifying, but all of these are rock that came from lava, or crystallizing. So much of this rock actually flowed as lava onto the ocean before it crystallized into rock, and it started piling up enough to eventually rise above the sea level and create new land. So that's kind of clear to see in this image, and also in this image here on the left and top. So a funny yet still pretty useful natural function provided by a volcanic eruption of this sort is the creation of further land and a further shoreline. And as we saw this happening actually in the Kilauea eruptions that happened in 2018, for example, a fair amount of new land actually got created, a fair amount of new shoreline. So here in this slide I have a few other examples of natural hazard service functions. The top left here shows us how an oil reservoir was able to get trapped, literally, only by the shifting of the layers that was caused from the seismic activity on a fault line. So before that, this kind of blue area used to be together with this one, so the oil could have migrated to the surface. But because of the shifting of those layers due to the fault, and hence the seismic activity, that oil is now trapped, and then we can later recover it. And as you know, we use oil a lot for electricity production and heat. The example that you have next to it over here is a flooded terrain, as you're seeing. With all of that water that floods, there typically comes some finer sediments that come with the water. So those finer sediments can be things like silt and fine sands. Those would be the sizes that you're looking at. And with the flooding, you also get many organic materials as well. So once that water that is sitting on top drains, the sediments and the organics that it carried along with it are typically left behind. And these type of soils make really good soils for agricultural uses. So that's another good way to have nutrient restoration, if you would, from flooding events. As you see in the bottom left picture over here, this is another example where large boulders, which fall from rock falls somewhere in the cliffs above, they will fall onto the streams, and right downstream from the boulder, so if the stream is flowing kind of into the page, right downstream from the boulder, those are really good places for fish to accumulate. So it's kind of a good place for a fish to take a break, and hence it's a good place for fishing. So overall, there are many natural service functions from hazards, and as we go through the hazards on each chapter during the course, I will try to highlight as many service functions as I can think of. But I encourage you to do the same now, to think of more natural hazard service functions that are in your mind and jot them down. Again, I think you will have to put this in your assignment as well this week, so you might as well think of a few different natural hazard service functions. Alright, so finally, to summarize what we have covered in this chapter, I want you to think about the bullet points here and the questions that follow each bullet point. So go ahead and jot a few ideas after each statement that I make following the question, okay? So I'll help you with the first one. So the first bullet point says, hazards are predictable from scientific evaluation. Okay, so they're not 100% predictable, but many times a good forecast can be made from observation and from analysis. In truth, this is really by using the scientific method, right? So that would be kind of what you put here. How? It is by using the scientific method. And then you can actually write down what the scientific method is in that respect. Okay, second one. Risk analysis is an important component in our understanding of the effects of hazardous processes. So why do you think that is? Third one, linkages exist between different natural hazards. So here I want you to give me a few examples of what those links between natural hazards can be. Fourth, hazardous events that previously produced disasters are now producing catastrophes. So again, why is that? And then lastly, consequences of hazards can be minimized through mitigation or through, again, anticipatory response. So write a few examples for some mitigation or some anticipatory responses that you can think of. Alright, so with that, this is the end of the first lecture. Let me know if you have any questions about the content that you just heard and that you saw, or anything that I may have said that you did not understand or that was not clear.